forgot to hit the record button. All right, let's take a pause. Let me know if you have further questions. All good? Does it make sense? All right, so after that, just one more step. I'm going to bring the 40 and 60 out in parallel on the other side. And then I have 20 and 30. And 20 and 30 are in parallel because they are both connected here at the top node. And they're also connected at C. So both ends of the resistor are connected to their respective terminals to each other. Then they are said to be in parallel. And so 20 and 30 are in parallel. And then C has the 4 ohm resistor coming down. So the combination would be 20 and 30 in parallel, then in series with the 4 ohm resistor. And then these 3 branches, 40, 60, and this third branch, they're all in parallel. And so total REQ as measured between A and B is these 3 branches in parallel. And that's how we can reduce this circuit to one single resistance, REQ. All right. In the meantime, let me open up the other homework assignment. All right, resistors in series and parallel analysis. All right. Do the steps make sense? Yes. Any questions? Okay. And that was problem 2.5. 2.2 and the others, other straightforward. Does anyone have any questions about these problems? How about this one? Have you all attempted this yet? Usually students do have some issues with this problem, but if you are good with it, that's great. Yes. Can I solve it? Well, I'd ask students to solve it, and if they get stuck, feel free to ask questions. So what do we see here? It's asking us to create a resistance of 1.5K and you have a box of 1 kilo ohm resistors. So right off the bat, if you were to draw the circuit, if you just ignore the diagram for now, how would you create a 1.5 kilo ohm resistor if all you have are 1 kilo ohm resistors? How would you combine them? Yep, exactly right. So the answer was 1 kilo ohm in series and 2 kilo ohm in parallel. And those 2 kilo ohm in parallel would give us 0.5 kilo ohms, and the 0.5 kilo ohms in series with 1 would give us 1.5. So if we look at this diagram here, where can we see 2 parallel connections? The first 2 branches They are in parallel right here. Right, is my cursor visible? Yeah. Right. So you would put the 1.5 kilo, 1 kilo ohm resistors in that place, and you have 1 kilo ohm right here. Now, what else do we have available here? We have a 1 kilo ohm vertical, we have a 1 kilo ohm horizontal, and we have this open circuit. So what do you think is the purpose of that open circuit as far as the problem goes? To cut off the rest of the circuit. So the answer or the solution to this would be you would place a 1 kilo ohm resistor here, place a 1 kilo ohm here and here, and you would place the open circuit right here. So the rest of the circuit does not matter. We can leave it blank. That's kind of like a conceptual or logical thinking. Nothing to do with like engineering per se or circuit analysis per se, um, but a little bit more intuitive and logical thinking. That's what they're asking us to do. And the similar thing for the next one. I think they have another one, and the same thing would happen here. To create a 2.2 kilo ohm resistor, you would follow the exact same thing. You would design your circuit or resistive network, and then once you place it on there, you place an open circuit somewhere in there. So try it out and let me know if you have any questions. Draw out the circuits and see what makes sense. So right now we are still in the prereq topic phase of this course, but the lecture videos on to node voltage analysis, mesh current analysis, those homework assignments are coming up. Okay. So I suggest you get these homework assignments done and out of the way. Get all your doubts clarified, because the next ones are going to require a lot of it's new material. So you're gonna have to watch the lecture videos, attempt the problems, and then come to class and have your questions ready so we can get those ironed out. How many of you are done with this one without any issues? Okay, hopefully others are still working on it. Great. Okay, this problem we already looked over. Let's see. This is does everybody have this one? Okay. You're almost out of time. This one is straightforward. I1, 12-volt source. Okay, this one I just want to talk about before you attempt this. It's asking us to find I2. Okay. So the way you would do this is, let me see, make sure. All right. So we are using resistive circuit analysis, meaning we reduce an entire resistive network down to one single resistance, meaning find total Req from the perspective of the source. The source can be a current source, can be a voltage source, does not really matter. So the perspective of the source, meaning we remove the source from our analysis and the points that are left behind, which would be A and then D at the bottom. So we need to find total Req between points A and D from the perspective of the source. Okay. Once we reduce it down to one single resistance, we can apply Ohm's law, calculate I1. Once you calculate I1, now you know the total voltage or the total current that's flowing through that circuit. Okay. So you can calculate the individual voltages across the 6 ohm and the 12 ohm at the top and at the bottom. Once you have those voltages, you find the individual currents that are flowing from the top, meaning through the 6 ohm resistor and the 12 ohm resistor, and the 12 at the bottom and the 6 at the bottom. Once you have those, you apply KCL at either node B or node C. And that KCL will give you the value for I2. Okay. Does that make sense? Intuitively, if you look at this, 6 and 12 at the top, 6 and 12 at the bottom, both are in parallel, then they are series. That means the 20 volt being applied is split equally in half. Half at the top, half at the bottom. So 10 volts between AB and AC, and 10 volts between BD and CD. You can do this mathematically, but if you have two resistors or you have two equal parts and you're applying a source across equal parts or dividing into equal parts, then the voltage also is divided into equal parts. You calculate Req for 6 and 12 in parallel or 12 and 6 in parallel, it's the same, right? So it's 12, 6 parallel at the top, 12, 6 parallel at the bottom. So it divides into 10 and 10. Okay. All right, we'll stop here today and pick up here again on Wednesday. Please attempt this homework problem or all the homework problems in here and then come to class on Wednesday so we can get these ironed out. And you can sit in class and submit your homework. And we'll call it classwork.